Welcome to Lesson 11, the moment CrowdSec stops just watching and starts blocking. Up until now, every detection has been reactive, parsing logs of attacks that already landed. AppSec flips that script. It's a built-in WAF, matured in version 1.7 that intercepts requests inline, SQLi, XSS, path traversal, all stopped before Nginx ever forwards them to your app. Add OWASP Core Ruleset, virtual patching for fresh CVEs, and your own custom signatures, and by the end of this lesson, your stack blocks OWASP top 10 at the door, without touching a single line of application code. So let's lay these two layers side by side. Scenarios are log-driven and reactive, brilliant at spotting patterns over time, like 5 SSH failures in 10 seconds, but the first malicious request always lands, and if there's no log, there's no detection. AppSec is request-driven and proactive. It inspects the URL, headers, and body inline, blocks the very first hit, and lets you virtual patch a fresh CVE in minutes. The trade-off? HTTP only, a millisecond or two of latency, and some tuning. The answer isn't either or. You run both. So what does AppSec actually catch? 5 classic attack classes, all stopped at the first request. Classic SQL injection like ID equals 1, OR1 equals 1. Pattern matched 403, source banned if it persists. XSS payloads with script tags, tag stripping detection fires. Path traversal with ... hitting etc. past WD, blocked. RCE attempts using command separators, blocked. And LFI or RFI pulling in external shells, blocked. Plus, rate limiting, user agent fingerprinting, and header anomaly checks layered on top. The full OWASP CRS, working out of the box. Now let's actually turn it on. 3 commands, that's it. First, install the virtual patching and generic rules collections that pulls down the base config plus the full OWASP CRS over 1,000 rules. Second, append a block to acquiz.yaml telling CrowdSec to expose AppSec as an HTTP endpoint on localhost port 7422. Third, reload the service and curl that endpoint. You should see status OK. Rules loaded 1247. Your bouncer now has somewhere to forward requests for inspection. With AppSec Live, let's trace what actually happens when a request hits your stack. An attacker fires a post to search with a classic SQL injection payload. Your Nginx bouncer catches it, forwards the body and URL to AppSec on port 7422, and the rule engine scans against all 1,200 rules. Match means a 403. Clean means forward to your app. Total overhead? 2 to 5 milliseconds. Malicious traffic dies at step 3, never burning your application's CPU or bandwidth. So what's powering those 1,200 rules? The OWASP Mod Security Core Ruleset, the same gold standard WAF logic used across the industry, organized into 12 900 series classes. The big 6 you'll actually care about. 942 catches SQL injection with patterns like union select and sleep. 941 shuts down XSS payloads, 930 blocks path traversal, 932 stops remote code execution like pipe bash or backtick WAMI, 913 fingerprint scanners like Nikto and SQL map, and 920 rejects malformed protocol violations. Anomaly scoring sums hits across all classes, so even sneaky low-confidence matches add up to a block. Here's where AppSec earns its keep. A critical RCE drops in some WordPress plugin, and you know patching means downtime, regression tests, change tickets. Meanwhile, the clock is ticking. But watch the timeline. CVE disclosed at T+0. The community publishes a signature around 2 hours later. Your hourly cron pulls it down 5 minutes after that, and you're protected. 1 line of cron tab plus the AppSec collection equals automatic CVE coverage within roughly an hour of disclosure, long before you touch the app itself. But the OWASP rule set can't know your business. It doesn't know that admin should never be reachable from the public internet or that a particular API token pattern is a smell. That's where custom rules come in. a tiny YAML file with a filter, an action, and an optional whitelist. This example blocks anything hitting admin/ unless it's coming from your internal CIDRs, and you can replay it against real logs with SQLi before it ever touches production traffic. Now let's wire AppSec into the bouncer you already deployed back in Lesson 8. No new daemon, just a toggle. On Nginx, you flip AppSec enabled to true. Point AppSec URL at the AppSec endpoint on port 7422 and decide what happens on each failure mode. Traefik mirrors the same idea inside the plugin middleware. Pay attention to the two knobs at the bottom. Failure block means AppSec actively said block. Unreachable block means AppSec is offline. In production, you usually block on the first and allow on the second, so a WAF hiccup never takes your site down. Before you ship this to production, here are the 5 gotchas that will absolutely bite you. 1. Legitimate passwords with apostrophes trigger SQLi rules. Whitelist the login route. 2. APIs with words like select in JSON bodies get nuked by CRS 942, tune the paranoia. 3. If your listening adder is 127.0.0.1, the bouncer can't reach AppSec and your WAF is silently off. 4. Reloads cause timeout spikes, set unreachable block to false. And 5. Custom rules without a zones field match nothing. Learn these now, debug less at 3 a.m. Step back and look at what you've built. 6 skills. You understand why AppSec and scenarios complement each other. Reactive log analysis plus proactive request interception. You can name the 5 attack classes blocked inline, enable the WAF in 3 commands, explain the 2 to 5 millisecond latency budget, lean on the OWASP Core Ruleset's 1,000+ signatures, and ride the virtual patching workflow when the next CVE drops. Lesson 12 is the capstone, full production checklist and multi-server architecture. WAF live, app protected, 4 checkboxes ticked, AppSec enabled, OWASP CRS active, virtual patching wired, custom rules deployed. That's Lesson 11 done. Next up, the capstone. Central LAPI on PostgreSQL, multi-server fleet topology, monitoring backups, disaster recovery. 1 lesson stands between you and full CrowdSec mastery. Load Lesson 12 and let's graduate.